Let's look at trig values given information about the angle. For example, let 12, -5 be a point on the terminal side of theta. Find the exact values of cosine of theta, cosecant of theta, and tangent of theta. Now, the first thing to notice is that this point here, 12, -5, does not lie on the unit circle. Because in order for a point to lie on the unit circle, x squared plus y squared has to be equal to 1. But looking here, we have 12 squared plus -5 squared is equal to 144 plus 25, which is equal to 169, which is not 1. Therefore, we cannot use the unit circle definition of the trig functions, but there is an equivalent one. That is, if xy is the point of intersection of the terminal side of the angle and a circle of radius r, then the sine of theta is equal to y divided by r, cosine of theta is equal to x divided by r, tangent of theta is y divided by x, cosecant of theta is r divided by y, secant of theta is r divided by x, and cotangent of theta is x divided by y. And we're assuming here that r is greater than 0, or that xy is not the origin. So in our case, we have that xy is equal to 12, -5, as shown in this figure here. So we'll find r by using this formula here. Namely, r is equal to the square root of x squared, which is 12 squared, plus -5 squared, or the square root of 144 plus 25, which is equal to the square root of 169, which is equal to 13. So let's write that on the graph up here. R is equal to 13. And now that we know r, we can find these three values here by using this equation, and this equation. That is, cosine of theta is equal to x divided by r, which is equal to 12 divided by 13. Cosecant of theta is equal to r divided by y, which is equal to 13 divided by -5, or -13 over 5. And tangent of theta is equal to y divided by x, or -5 divided by 12, which is -5/12. Let's look at another example. Let -3 square root of 7 be a point on the terminal side of theta, and let's find the exact values of sine of theta, secant of theta, and cotangent of theta. Again, our given point here does not lie on the unit circle because -3 squared plus the square root of 7 squared is equal to 9 plus 7, which is 16, which is not equal to 1. Therefore, we cannot use the unit circle definitions of the trig functions. So we're going to use these definitions instead. And here we have that xy is equal to -3 square root of 7, as shown in this figure here. So let's find r by using this equation again. Namely, r is equal to the square root of x squared, or -3 squared, plus square root of 7 squared, which is equal to the square root of 9 plus 7, which is equal to the square root of 16, or 4. So let's write that here in the figure. This is equal to 4. Now notice in both of these examples, we're basically doing the same work twice. Because looking up here, didn't we already know that r squared was 16? So basically, you would just have to take the square root of that number to get your r each time. All right, now we're ready to find the sine of theta, secant of theta, and cotangent of theta by this formula, and this formula. That is, sine of theta is equal to y divided by r, which is equal to the square root of 7 divided by 4. Secant of theta is equal to r divided by x, which is equal to 4 divided by -3, or -4/3. And finally, cotangent of theta is equal to x divided by y, which is equal to -3 divided by the square root of 7, which we then can rationalize. Which would give us -3 divided by square root of 7 times square root of 7 over square root of 7, or -3 square root 7 divided by 7. And this is how we find trigonometric values given information about the angle. Thank you, and we'll see you next time.